निर्मळ नो अभिगम कल्याण हो छात्र नो हरदम उच्च अभ्यास नो शिक्षण धाम महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल.
Hello students, in this session we will be dealing with the introduction and solution for exercise 2.2 of chapter 2 polynomials from your class 9 NCERT textbook mathematics. Here we will be learning to find the value of the polynomial for some value of x. That means for different values of x the polynomial will have different values. First, that means if we change the values of x, we get different values for p of x. But if we change is the secondary thing. First, at a particular value of x, what is the value of the polynomial? So let us move on with your example from your textbook only. That p of x is equal to 5x square minus 3x plus 7, and we need to find the value of the polynomial at x equals to 1. That means substituting this value of x everywhere wherever we see x in the polynomial, we will be getting the value of this p of x. How? Now if we take the value of x, we can write this one as p of 1, and this is equal to, for everywhere there is x, we need to substitute 1. So this is 5 into 1 square minus 3x, and in place of x, you have to again write 1 plus 7. So wherever we have x, here we have x square, so value of x was 1, so 1 square. Here we have x, so the value of x is 1, so we have substituted the value of x is equal to 1 plus 7. That is, now we solve it. This is 1 square is 1, so this is 5 into 1 minus 3 plus 7. This is 5 minus 3 plus 7. So 5 minus 3 is 2 and 2 plus 7 is 9. So this is the value of the polynomial. Which polynomial? The given polynomial for the given value of x, that is x is equal to 1. That is, if we do the value of x in the given polynomial, finally we get the value of the polynomial to be 9. Of the polynomial means, let us see what we mean by zeros of a given polynomial. Zeros of a polynomial is that value of the variable is that value of the variable which on substituting in the polynomial makes the value of the polynomial to be 0, makes the value of the polynomial to be 0. Zeros of a polynomial. That means if a polynomial is given to us and that polynomial, we need to find the zeros of that polynomial, all those values of the variable that is present in the polynomial. If on substituting those values in the polynomial, if the total value of the polynomial becomes 0, then we say that particular value of the variable is the 0 of the polynomial. Suppose we can say, we can take say p of x is equal to x plus 2. Suppose this is the example that is given to us. P of x is equal to x plus 3. So we are looking for such value of the variable x that will make the total value of the polynomial to be 0. And if we get that value is called the 0 of the polynomial. So how do we find that 0 of a polynomial? Suppose on substituting this polynomial becomes 0. So let us assume initially only that p of x is equal to 0 for some value of x. And what is that value? Simply by solving just like linear equations. If p of x is equal to 0, then what we want to get, and p of x is x plus 3 is equals to 0, so x is equals to minus 3. On solving simply just like a simple equation, we get the value of x to be minus 3. Now if we check it, if we put this value of minus 3 in the polynomial, the value of the polynomial as a whole becomes 0. So we can say here minus 3 is the 0 of p of x. That means at this value the polynomial becomes 0. We can take one more example if we want. Suppose we are given that p of x is equals to 2x minus 5. Suppose we are given this way. The polynomial is p of x is equals to 2x minus 5, and we need to find that 0 of this polynomial. 0 of this polynomial means such value of x that will make the whole value of p of x to be 0. So let us find out. Initially, we consider the polynomial to be 0 itself because we want to get that polynomial to be 0. And what was p of x? That is 2x minus 5. If p of x is equals to 0, then we can say 2x minus 5 is equals to 0. Simply by solving like simple equation, we can find 2x is equals to 5 and x is equals to 5 by 2. So at this value of x, the total polynomial becomes 0. So we can say 5 by 2 is the 0 of the polynomial. 0 of the polynomial, that is p of x. Moving on to the next example. Check whether minus 2 and 2 are zeros of the polynomial x plus 2. So we are given with the polynomial p of x is equals to x plus 2. And we have to check that minus 2 and 2 are the zeros of the polynomial. Zeros of the polynomial means if we substitute the value minus 2 in place of x everywhere, if the polynomial, the value of the polynomial becomes 0, then we can say minus 2 is the 0 of the polynomial. If it is not 0, then we can say minus 2 is not the 0 of the polynomial. So let us check for both the values minus 2 and 2, and we will be substituting minus 2 and 2 in place of x. So first minus 2, that is x is equals to minus 2, that is p of x. That is p of minus 2 is equals to minus 2 plus 2 is equals to 0. While substituting the value of x is equals to minus 2, the polynomial becomes 0. So we can say minus 2 is the 0 of the polynomial. Therefore minus 2 is the 0 of our polynomial that is given to us as p of x. This is the first that we have checked for minus 2. Now let us check it for 2. That means at x is equals to 2, and p of 2 is, if you substitute the value for x to be 2, now we have 2 plus 2 and that is equals to 4, which is not equals to 0. If it is not equals to 0, that means x equals to 2 or the value 2 is not the 0 of the polynomial p of x. Therefore, we can say 2 is not the 0 of the polynomial that is given to us as p of x. In other language, the zeros are also known as the roots of the polynomial. Roots of the polynomial. But 0 of the polynomial is frequently used in polynomials. Moving on to the next question. Example number 4. Find a 0 of the polynomial p of x is equals to 2x plus 1. Now what we have to do? We have to find the 0 of the polynomial. The polynomial is given to us as p of x is equals to 2x plus 1. We need to find the 0. That means we need to find such value of x that makes the polynomial to be 0 on substituting it. So for that, we have done in our previous example also. We first of all take p of x is equals to 0 because if it is 0, then only we can get the value of x. And what was p of x? That is 2x plus 1, that is equals to 0. Solving this by simple equation form, we get the value of x. So 2x will be equals to minus 1 and x is equals to minus 1 by 2. This value of x is called the 0 of the polynomial that we have asked. Therefore, x is equals to minus 1 by 2 is the 0 of the p of x that was given to us. Next example. Verify whether 2 and 0 are the zeros of the polynomial x square minus 2x. So we are given with the polynomial p of x is equals to x square minus 2x. And we have to verify, we have to check whether 0 and 2 are the zeros of the polynomial or not. That means at x equals to 2 and x equals to 0, if the polynomial becomes 0, then they are the zeros. Hence we can say verified, else not verified. So let us take as x is equals to 2. Then what is p of 2? P of 2 is 2 square minus 2 into 2. In place of x, we have substituted 2. P of x, the x is 2. So here also x is 2. Here also x is 2. And then we solve it. 2 square is 4 minus 2 into 2 is 4, and this is equals to 0. That means we have got the value of the polynomial to be 0. So we can say 2 is the 0 of the polynomial. Let us check out for the next value at x equals to 0. So p of 0 will be equals to x square minus 2x. So 0 square minus 2 into 0, substituting the value of x to be 0 in the given polynomial. So this is 0 square is 0 minus 2 into 0 is 0, and this is also 0. That means at both the values we have seen that at x equals to 2 and at x equals to 0, the value of the polynomial becomes 0. That means both the values of x are the zeros of the polynomial. Hence we can say, hence 2 and 0 both are zeros of the polynomial that is given to us, that is zeros of the polynomial p of x is equals to x square minus 2x, and hence we have verified. What we have verified? That both the values 2 and 0 are the zeros of the polynomial. Moving on with the exercise 2.2, question number 1. Find the value of polynomial 5x minus 4x squared plus 3 at three different values of x. X equals to 0, x equals to minus 1, and x equals to 2. That means we need to find the value of the given polynomial at three different values of x. X equals to 0, x equals to minus 1, and x is equals to 2. So we are given the polynomial p of x is equals to 5x squared, 5x minus 4x squared plus 3. And we need to find the value of the polynomial at x equals to 0. That means we will have to substitute the value of x to be 0. So let's find out p of 0. So everywhere wherever we have x, we have to substitute 0. So 4 into 0 square plus 3. So 5 into 0 is 0. 0 square is 0 into 4 is 0 plus 3. So the value for the polynomial p of x that is given at x equals to 0 is 3 that we have got. Now moving on to x equals to minus 1. We are given with the polynomial p of x is equals to 5x minus 4x squared plus 3. And we need to find the value of the polynomial now at x equals to minus 1. So let us substitute minus 1. So p of minus 1 is 5 into minus 1 minus 4 into minus 1 square plus 3. So 5 into minus 1 is minus 5. Minus 1 square is plus 1, and plus 1 into minus 4 is minus 4, and then plus 3. So this is minus 9 plus 3, and this is minus 6. So the value of the polynomial p of x at x equals to minus 1 is minus 6. Moving on at x equals to 2 for the same polynomial that is given to us, and the polynomial is p of x is equals to 5x minus 4x squared plus 3. And now we will be finding the value of the polynomial at x equals to 2. So let us substitute the value of x to be 2 and find out the value of the polynomial. So this is 5 into 2 minus 4 into 2 squared plus 3. So this is 5 to the 10. 2 square is 4, and 4 into minus 4 is minus 16 plus 3. So this is 10 plus 3, 13 minus 16 is minus 3. So the value of the polynomial P of x that is given to us at different values of x. We have obtained at x equals to 0 to be 3, at x equals to minus 1 to be minus 6, and at x is equals to 2 to be minus 3. Next question is question number 2. We need to find P of 0, P of 1, P of 2 for each of the following polynomials. There are 4 bits in the question and we will be doing 3. 4 you can do it for your practice purpose. We need to find the value of P of 0, P of 1 and P of 2. We are given with the polynomial P of y is equal to y square minus y plus 1. That means we will have to find the value of P of 0, that means y equals to 0. P of 1, that means y is equals to 1. And P of 2, that means y equals to 2. So let's find that. P of 0, that means what we have taken? We have taken the value of y to be 0. So everywhere we will have to substitute the value of y to be 0. So this is 0 square minus 0 plus 1. If you solve it, this is the value is 1. 0 square is 0, 0 minus 0 is 0 plus 1 is 1. Then let us move on to P of 1. That means we are taking the value of y to be 1 and substituting in place of y. So this is 1 square minus 1 plus 1. If you solve it, this is 1 minus 1 plus 1 and this is also equals to 1. Then let us move on to the value of P of 2, taking y to be 2. This is 2 square minus 2 plus 1. 2 square is 4, 4 minus 2 plus 1, and 4 minus 2 is 2 plus 1. The value is 3. So P of 0 is 1, P of 1 is also 1, and P of 2 is 3 for the given polynomial. P of y is equals to y square minus y plus 1. Next, bit 2. P of t, now we have the variable t. P of t is 2 plus t plus 2t square minus t cube, and again we will have to find P of 0, P of 1, P of 2. That is changing the values of t to be 0, 1 and 2. So let us move on with P of 0, taking the value of t to be 0. This will be 2 plus 0 plus 2 into 0 square minus 0 cube. If you solve it, this is equals to 2 plus 0 plus 0 plus 0, and that is equals to 2. So P of 0 for the given polynomial is 2. Then we will be moving on P of 1. So 2 plus 1 plus 2 into 1 square minus 1 cube. So we have taken the value of t to be 1. So this is 2 plus 1 is 3 plus 1 square is 1 into 2 minus 1 cube is 1. So this is 3 plus 2 minus 1, 4. That is the value of P of 1 is 4. Moving on to the next P of 2. Taking t to be 2, this is 2 plus in place of t we can take 2 plus 2 into 2 square minus 2 cube. Let us solve it. This is 2 plus 2 is 4 plus 2 square is 4. 4 to the 8 minus 2 cube is 8. So this is also 4. That means for changing the value of t to be 0, we have 2 for t equals to 1, we have 4 for t is equals to, we have again 4. Moving on to bit 4. This one is bit 4 from the textbook and bit 3 is for your practice. Again we will have to find the value of P of x for P of 0, P of 1 and P of 2. That is changing the value of x to be 0, 1 and 2. Here the variable used is x. So let us find out. So P of 0. So this is 0 minus 1 into 0 plus 1. So 0 minus 1 is minus 1. 0 plus 1 is plus 1. So minus 1 into plus 1 is minus 1. Then let us move on to P of 1. This is in place of x, we have to put 1 minus 1 and 1 plus 1. So 1 minus 1 is 0 and 0 into anything is 0. Here 1 plus 1 is 2, so 0 into 2 is 0. Then we will be moving for x is equals to 2. So this is 2 minus 1 into 2 plus 1. So 2 minus 1 is 1 and 2 plus 1 is 3. So this is 3. So in this way, we can find the value of any polynomial with any variable by changing the values of the variable. In this question, we can see we have changed the values of variables, that is 0, 1 and 2. We have changed the value of variable to be 0, 1, 2. And for each change in variable, we have obtained a particular value for the polynomial. Question number 3. Verify whether the following are zeros of the polynomials. There are various bits given in the question to verify and check whether the given values of the variable makes the polynomial to be 0 or not. That means the value of the given polynomial is the 0 of the given polynomial or not. There are various bits, out of which we will be doing 4 bits for you and the rest you can do for your practice. So let us move on then one by one. Make one. Verify whether the following are zeros of the polynomial. The polynomial given is p of x is equals to 3x plus 1 and we have to check for the value x is equals to minus 1 by 3. That means if we substitute the value of x in p of x and if the value becomes 0, then we can say that x is the 0 of the polynomial. So let us check p of minus 1 by 3. So in place of x we are substituting minus 1 by 3 plus 1. This cancels. This is minus 1 plus 1 and this is 0. So at x is equals to minus 1 by 3, the polynomial, the value of the polynomial becomes 0. So we can say x is equals to minus 1 by 3 is the 0 of the given polynomial p of x. Here, moving on to bit 2. P of x is equals to x square minus 1 and we will have to check for two values of x equals to 1 and x is equals to minus 1, whether they are the zeros of this given polynomial or not. If on substituting we get p of x to be 0, then we say they are the zeros. So let us move on. First of all, at x is equals to 1, that means p of 1 is 1 square minus 1 is 1 minus 1 is equals to 0. Then let us move on for p of minus 1 in place of x. We will be substituting minus 1. So minus 1 square minus 1. Minus 1 square is plus 1. Minus 1 is equals to 0. In both the cases, at x is equals to 1, at x is equals to minus 1, the value of the polynomial becomes 0. So we can say both the values are the zeros of the given polynomial. That is 1 and minus 1. Both are the zeros of the given polynomial. What is the name of the polynomial? P of x. It is verified. Now bit 6, this one for you. P of x is equals to Lx plus m, and for the value x is equals to minus m by L, we have to check that whether it is the 0 of the polynomial or not. So let us check. So p, in place of x we will substitute minus m by L. So in the polynomial also L, and in place of x minus m by L plus m. So L and L cancels. This is minus m plus m, and this is also equals to 0. So we are getting the value of the polynomial to be 0 and x is equals to minus m by L. That means minus m by L is the 0 of the given polynomial. So we can write minus m by L is the 0 of the given polynomial, that is p of x. Moving on to bit number 7. P of x is equals to 3x square minus 1 and we have to check for values of x as minus 1 by root 3 and 2 by root 3. We will have to check both the values. If on substituting both the values in the P of x, if the value of the polynomial becomes 0, then we can say these are the zeros of the polynomial. So let us check out. This is P of minus 1 by root 3. So 3 into minus 1 by root 3 whole square minus 1. We substitute the value x is equals to minus 1 by root 3 wherever we have x in the polynomial. So this is 3. If you square it, minus becomes plus and 1 square is 1 and root 3 square is 3 minus 1. So this cancels 1 minus 1 and that is equals to 0. So let us check here for your reference. This is 0. That means minus 1 by root 3 is the 0 of the given polynomial. So let's check out for the second also. So P of 2 by root 3 is 3 into 2 by root 3 whole square minus 1. So this is 3 into 2 square is 4, root 3 square is 3 minus 1, which is cancelled, and 4 minus 1, this is 3. That means out of the two values, in one of the values the polynomial becomes 0. If the polynomial becomes 0, that means that is the 0 of the polynomial, and in the second value where the value of the polynomial is not 0, that means that value is not the 0 of the polynomial. So we can say minus 1 by root 3 is the 0 of the given polynomial p of x, and 2 by root 3 is not the 0 of the given polynomial p of x. So this way we can check whether the given values of the variable are zeros of the polynomial or not. Number 4. Find the 0 of the polynomial in each of the following cases. There are various cases given in the question. There are various bits of the question, out of which we will be solving 4, and the rest you can solve it by yourself for practice. Find the 0 of the polynomial in each case. 0 of the polynomial in each case means those values of x that will make the polynomial to be 0. We had discussed it. What we will have to do? First of all, we will have to assume that p of x is equals to 0, and we will find the value of x. So we can say p of x is equals to 0. That means x plus 5 is equals to 0. So x is equals to minus 5. So this minus 5 is the 0 of the polynomial. That means we can say minus 5 is the 0 of the given polynomial p of x. So at this value, the polynomial will become 0. Moving on to bit 3, p of x is equals to 2x plus 5. Same way we will be moving as we have done in the previous bit. We will assume that p of x is equals to 0. That means 2x plus 5 is equals to 0. That means 2x is equals to minus 5, and x is equals to minus 5 by 2. That means at this value of x, this polynomial becomes 0. So minus 5 by 2 is the 0 of the polynomial p of x. Then bit 6. Same way, for all the questions the method is same. You need to find the 0 of the polynomial p of x is equals to ax. Only the polynomial is changing. The method of solving and the method of obtaining the 0 of the polynomial is same. So we can say p of x is equals to 0. Here the condition was a is not equals to 0. Why that a is not equals to 0 we will see. That is ax equals to 0. So x is equals to 0 by a. Now we have got 0 by a. If a could have been 0, the whole value has not been defined. We haven't learned anything upon 0 is not brought to us. So if it is 0 by 0, then the value is not defined. But 0 by anything, the value apart from 0, then we can say that x is equals to 0. That means here 0 is the 0 of the polynomial p of x that is given to us. Moving on to the bit 7, p of x is equals to cx plus d, where c is not equals to 0 and c and d both are real numbers. The method is same. P of x is equals to cx plus d. We take px to be equals to 0, and that means cx plus d is equals to 0. Solving same way as we solve the simple equations, we can write cx is equals to 0 minus d. So that is cx is equals to minus d, and x is equals to minus d by c. D and c both are real numbers as given. So we can say that minus d by c is the 0 of the polynomial p of x. So this way we can find the zeros of the polynomial for various types of polynomials. But if you notice here, all such polynomials that were given to you were linear polynomials. That means the degree of the polynomials was 1. So when polynomial is given to you with degree 1, you can have only 1 zero of that polynomial.